Hello, everyone. My name is Mr. Fernando Cepeda, and I'm here to present projects for our STEM um, conference. Like I mentioned, my name is Mr. Fernando Cepeda, and I've been a teacher for about 14 years. I've been in Harmony Public Schools for the last 10 years. I love teaching. I was actually named Teacher of the Year back in 2019, and I was also number one top STEM teacher, also back in 2019. And I've been involved with different other activities here in school, like SHEP, which is Society of Hispanic Professional Engineers, Solo Rollers. I've been coaching a Solo Roller team for the last 3 or 4 years. NHRA, Spanish Club, Folklorico Dance Team, and I'm pretty much everywhere. Um, Robotics, I'm also been involved with robotics, and actually came up with the idea of an all girls team, and they won this Emerald League tournament. They won the Thinking Award, and then I was also named Coach of the Year that particular year back in I think that was 2016 or so. And then I pretty much pushed my students and towards victory back on 2019 as well, and we our team won district competition, and there are some pictures there. So I'm going to pretty much use this sort of website to talk about the different sort of projects that we do here in high school, especially PBLs. And so, what is a PBL? This project-based learning. It's a way to first do projects so that students can be hands-on and learn. And then second, it is also a way to collaborate with other classes from the school. Um, it doesn't matter which class, it's just like finding a way to connect with them so that you can help the student understand everything that surrounds a project by talking to other teachers about his experience and or to get help from other teachers for his experience. So I'm going to be using this website. I created this website a while ago. It's still a work in progress. It is called harmonyengineering.weebly.com. And so I'm going to go through some of the projects that I've done in some of my classes. The first sort of project that I would like to talk about is this circuit project. It involves like all different kinds of circuits, like parallel or series. It's pretty much basic circuits. And so the students have to build circuits in this particular PBL. But I'm going to use this so that you can pretty much understand the different phases of a project, and so that I can just later on concentrate and talk about the different projects that I have in engineering here in Harmony. So we pretty much, just like in any other class, begin talking about some sort of theory, and then we pretty much connect that with other classes. Like in this one, our main goal was to talk about circuits and the different kinds of circuits, but we also talk about theory. In this case, we had Ohm's law, and with Ohm's law, we have to talk about fractions. So then I talked to other departments, especially in math, and then I pretty much asked how can I help to better work with fractions. And so this sort of like came up, and the homework that they were doing fractions in her class, and then they were doing circuits in my class. And I also connect with physics, because physics also talks about circuits. So it's a way of connecting several classes at the same time. But we'll begin with a little bit of intro to the project. We talk a little bit about theory, and then after that, we pretty much give the students a problem. And in this particular case, the problem was to be able to build the circuit. And so they could use like different components. Like you can see, this one is a little bit more elaborate. This one it's a little bit less elaborate. It is using a breadboard and battery packet there and some LEDs. And then the students have to present their projects every time. So every time they do a project, they need to talk about it, and it's we get a great response in like grades 10, 11, and 12. But for some sort of reason in grade 9, it's a little bit challenging to bridge that gap because the students are a little bit shy. They don't want to talk so much. I had students approach me and they're like, "Oh, Mr. Cepeda, can I just please present after school when I'm alone?" And I'm like, "No, like you need to present in front of everyone. You need to present in class. Take your time. Perhaps you want to sit this experiment out, and then you eventually you need to talk in front of people, so that they can pretty much get their confidence going and they can feel good about themselves, and then they get used to be able to talk in front of people. That's pretty much our main goal. So anyways, we start with a little bit of theory. We give them a problem. They have to present once their experiment is done, and then they have to have this sort of journal. So they need to have this engineering journal where they talk about the different ideas that they have and the approach. They do a little bit of research about their experiment. And then this is a great way to connect with other classes because here we can talk about grammar. We can talk about the way they talk, about the way they describe their experiments. So this sort of like writing connects with the English department. And this helps out a lot, especially with our ESL students, because since they're learning the language, this is a good practice for them. And then not only do they get to learn about it here in engineering, but also in a regular English class, and it helps them to practice. So sometimes they record themselves and then they practice, and that's a way to pretty much improve their skills. Sometimes we get a little bit more complicated, but it all depends on the experiment. In this particular one, we began to talk about sound circuits, and I use this lab, this sort of lab called Elenco. It has a manual, and I love this sort of manual because it gives you a brief explanation of what the experiment is about. It gives you the schematics of the experiment. It gives you a wiring sequence, and then it gives you how your project should look like by the time you finish. So I love this because then, once the students are done, then they can check their wiring with the picture. I also ask them to use it in their journal. So that will be kind of like the first steps will be to intro the topic. And then I ask them to draw the schematics in their journal. And then I give them the set of instructions. And then I ask them to use this other software, which is called Multisim. And that's for creating circuits and testing circuits. It's a virtual application that we use in computers. But I like this particular one because it has live. So it's called Multisim Live. And so the student can build their circuit in a live session. And so it doesn't matter where they are at, as long as they have internet access, then they can pretty much build it. And they can test it, and they can pretty much observe how how to put it together. They can find all these different parts with a little basic knowledge of electronics. They understand about, the different components and their electronic symbols, so they can find, capacitors or transformers or like all the different electronic components. So that's another tool that I use with this particular experiment. And then after they're done, we actually use this other program called Tinkercad. And with Tinkercad, once they know what they're building or what they're doing, they can find all the different parts of their experiment here in Tinkercad. And then they can use a breadboard, and then they can put all the components together, and then they can test it. So once again, not only can they test here using a computer, they also can test here using their computer. And then once they're done, then they get to build them. So then they build all these different circuits. Most of the time we start with sound circuits because they're the most fun because they create a sound. And so I allow them to do like 5 or 6 different experiments, or as many as they want, in a process of like 1 week or 3 different classes. And they're using wires, they're connecting components, they're observing what they're connecting. And then once they're done, they create a sound. And so here's an example of that. So once somebody has that sound, then everybody else gets excited, and then they want to be able to finish, and so that's great for that. They also get to troubleshoot if something doesn't work. Then they get to talk about it, and then they learn how to like connect everything together.
Well, like first I connected like all of the wiring where it's supposed to be and check that the wiring were like messed up because if they were messed up, like one of them would like burn out and it would damage the whole thing. And then I had to switch some wiring too because like they were dead in order for it to work. Yeah. See?
So the best thing is that they're learning, then they're looking at the different components, they're building their own circuits. And so once they're done, that would be the second part of this particular project. I asked them to build their own circuits with their own parts. For some students, this is a little bit intimidating, but for students that actually, begin to like the whole world of circuits, it's like a fascinating thing. And so they begin to research all these different components for their circuit. The advantage is that they already built the circuit here, and so they're going to build again the same circuit, but this time they're going to use their own parts. And so they have to look for a speaker, they have to look for voltage, some batteries, some component, a transformer, all those different components so that they can pretty much put it together. And so they have to be a little bit artistic to put everything together, all the information, little graphs. And so that, again, you can pretty much connect with mathematics because you can talk about graphing, you can talk about data, you can talk about like all these different topics for that particular classroom. And so you would either ask the teacher, ahead of time that you're doing this with them and that you're going to be using graphs. And so perhaps the teacher can talk about graphs in their classroom and ask for, something easy as a worksheet or something that they can turn in with their project. So that would be a way to connect with this other class. But as you can see, they have their own different components and everything so they can put together. And then once they're done, they have to create a website. The way to create websites is an easy process. I use Weebly, but there's also Wix, and there's this other different things that are websites that allow you to create websites. So the easiest one is Weebly. So we use Weebly. And as you can see, they use a title for their experiment, and then they talk about the problem that was assigned to them. They talk about the solution that they thought of doing, and then they provide some sort of evidence in the form of videos. Like I was showing how they were creating that particular circuit that I gave them earlier. And then you can see the Tinkercad version here, all the different components here, and they can add it here in the middle, and then they can test it. And so they can virtually test their experiment before they get to build it. And that's important because if it works here, then it should work once they build it. And so then they need to add a little bit of sources, and then they give their feedback. I like these web pages or the way to do these web pages because they can keep all their projects organized and they can keep all the information organized. And you can see the different tabs here and all the different projects for first semester, for second semester. There's a list of different videos from the first semester and second semester that they watch. And so there's a copy of their journal as well in this particular web page. So that in itself, it's a different project. So anyways, that would be kind of like the last step. It would be to pretty much put everything together, to post all the project together that we have going. So just to recap, the student is expected to pretty much pay attention during lecture, during class, so they can pretty much understand what they're doing, what they're building. We give them a problem, they come up with a solution. Once they have the solution, they have to pretty much do different ideas in their journal and document everything, put annotations along the side, put different designs there. And then once they are done with that, then they need to create their project, their prototype. And once they create their prototype and it works, then they need to share it with the rest of the class by talking about their whole experience, the mistakes that they made, and the way they approached the problem. Once we're done with that particular project, which is a simple circuit, simple basic circuit with either going from parallel or series kind of circuit, then once they've done those ideas in their journal, they build it. Once they build it, they test it. Once it's tested, then they compare with other projects by doing this sort of like virtually testing their project to see if it works. And so they have this sort of software, live multisim live, and then they have this other software called this other application called Tinkercad, so that they can test again. And then once they're done, then they get to pretty much build it on their own. And then once they build on their own, then they present to the rest of the class the whole experience. And then once they're done with that, then they use that and then they post it to their website. And then in their website, they talk about the whole process again, the different components. Was it easy? Was it hard? And then we pretty much share all of that. And all these feedbacks and all this writing, it's also a way to connect with other classes, because other classes can focus on grammar, they can focus on social studies and or speech, so that they can, voice out their whole experience. So that's one of the projects that I wanted to pretty much talk about, the whole process of the project, or the evolution of the project itself, so that you can pretty much understand how I use the different projects from class to connect with other classes, and also what's expected within that process of each project. So now I'm going to talk about all the different projects that we have for our engineering class. And so, like I was saying earlier, I'm going to use this website. So I'm going to go to this other one here called the Rube Goldberg. So here's a Rube Goldberg experiment, and it's pretty much a collision kind of experiment. One thing triggers another, and then it triggers another, and then you use it to state that there's all these different technologies and all these different areas of engineering that in the end get together to be able to put something together like this here. So we have different videos. They have to create a video, and then they have to expose their video during class. And so this particular one was, they had to pop up a balloon. And so here's their Rube Goldberg machine. And that was a fail. And then they tried it again. That was a fail again. And then they tried it again. And they talk about their whole experience, the mistakes that they made, the different tries that they had to do. Go. And then, as you can see, there's excitement involved through the process. Here's another one.
Hello, everyone. So I'm getting ready to present y'all my Goldberg machine. My Goldberg machine, and I'm going to explain y'all the function of each station that contains the machine. So to start off, this machine, this book is going to be. I'm going to throw it like that. What this is going to do is going to drop the boxes that are in this seat. So as you can see, there's this bag of oatmeal placed on top of this box. The function of this is to turn on the lights. So, like I said, I'm going to be using two core technologies at once. The first one's electricity, which I'm using electricity to turn on the light, and the light bulb could be considered as optical energy because I'm using a light bulb, and it's considered as using light, which is heat, could be considered as heat. So once this has been thrown like this is going to fall, and it's going to turn on the light. Throw this ball in a box, and it's kind of to have as so it can. These Batman is he was playing this game. Use that as my message. His Goldberg machine, and let's get started. 1, 2, 3.
And so there you go. There's a lot of excitement through the projects. But anyway, that was another one of our projects. It's called the Rube Goldberg, and we use it to pretty much express different engineering core technologies working together. Then we have this other one called the board game. And the board game, we talk about the different ages of technology, and then they pretty much have to create a board game that they build themselves. Everything is custom made by themselves, and then they have to choose a different age of technology as their theme. But what I like about this is that sometimes they get so creative, and then they build or they a way to demonstrate their whole experiment will be like through a skit. And for this particular one, I like this skit that they come up with.
Are you tired of your kids being on the phone? Get this board game now.
This is fun!
Did you see how much fun these kids were having? Well, you can get this game board at paralympicboardgame.com or call us at 1-800-PARALYMPIC just for $19.99. You can get a special offer if you call now. You buy one, get one half price. También hablamos español. Nos puedes visitar para conseguir este juego en nuestra página web paralyticboardgame.com. Nos puedes contactar a nuestro número telefónico 1-800-PARALYTIC. Este juego es tan barato y tan sencillo que lo puedes conseguir hasta en las tiendas. Cuesta $19.99. También hablamos mucho español, por si acaso.
So there you go. You have it. They sometimes they have a creative way of dealing with presenting their experiments. I like this other one too.
What game is that? Bringing you cheating. That's not. It says you have to find the guys. Dude, I'm gonna beat you, like, seriously right now.
Do you ever feel bored at home and have nothing to do?
Yeah.
Now with the Maze running game, you can take all that boringness off your shoulder. Call now. It's $10.99. If you call now, you get 50% off. This game is based off the Iron Age.
Yeah, you can get it at your nearest Harvey's Science Academy store, or just come to Harvey Science Academy School. If you call 1-800-IRON-AGE, you can get 50% off.
So there you go. There's their skit. As you can see, they tend to come pretty creative about it to be able to present their board game or talk about their board game and their age. And then you can have that connection with SS or speech or ELA or even art. And when they show their video, teachers give them their feedback about the videos and how to either make it better or how to use different things. Here's another one. This is from their website. This particular one, they used the tic-tac-toe, and then they had rocks, and then the color on the rocks represents like a different team. So that's another experiment. And let me see if I can move to another one here. We have the where we talk about the eatable car. I like this experiment as well because they design it. They pretty much have to come up with an idea on how to create a car made out of edible materials. And so everything in those cars is edible. Nothing cannot be not edible. And so then they come up with like different things, and then they have to create their own videos.
So this is my engineering car project, and we were supposed to make a car, a race car, out of entirely of food. As you can see, it's made out of food, and it's supposed to roll down a ramp. Now the thing is with this is that the car has to roll down a ramp without braking, and it has to look like a car. And you know, I would say it looks like a car. Some people would argue it doesn't, but I think.
So as you can see, they come up with their video. They talk about their whole experiment. This is because we are in pandemic. They had to pretty much build their own ramp because when they're here, I provide a ramp, and then they pretty much run their experiment through the ramp 3 times, and then their experiment should not come apart. So here are some examples from class that they built. And here's how they pretty much design in their journals. And then this is using a CAD software, so they can pretty much do the expectation of their car and how the car looks like using that sort of software in their computer. And then they get to build it, and then they present during class. And here are like different examples of the different kinds of cars that we have made like through the years. And that's the edible car project. And so I should have another one here. The rice and beans. So this is like a sorter machine. They have to come up with the ways to separate a mixture, and this particular mixture is a mixture of rice and beans, and so they have to come up with some sort of solution to be able to separate them. And so here's one of them. You can see they added like little motors and batteries to make the whole experiment vibrate, and as it vibrates, it goes into one container for rice and then the other one for beans. And so here's another sort of approach. This is another different approach. But you can see in the end, they're able to separate the beans from the rice. So that's an approach. That's an experiment. And then here, I already talked about this. And then this one, I already talked about this. This is the sound circuit. And then this one. This I do with robotics, and I pretty much show them how to build a robot. And then here they pretty much talk about the whole experience to be able to build a humanoid robot. So there's the materials that were provided to them. They use a manual. They use the Tetric system in robotics. It's about $400, $500, but you can reuse them every year. And then you can see the manual there. The manual goes like step by step. And then you can see a little fast, the camera a little bit on how they were able to put that together with their components to be able to make that humanoid. You can see that how they're attaching the different wires that are required to be able to move the different motors and the different things on the humanoid robot. It's a great experience, and it can be worked at all different levels. You can talk about different components of the robot, the transmitter, the receiver, the different gadgets. You don't get to code it until you get to like later on grades, but this is perfect for them to kind of like be exposed to the world of engineering and robotics. So that's a great experiment with robots and robotics. This one here I love. It's called the House Chore Solution Project, and the problem is they're faced with all these house chores, and they pretty much are thinking of a way of making that easier. So, for instance, this one, she commented that the way they used to clean the fan in their ceiling, they had to use this ladder, and then they had to pretty much use a towel and wet the towel and then like clean it. But then she come up with an easier version of it to where she can use this little extension, and then she's able to reach out there, and so she could use that as her experiment. Let's take this out.
We at 4Ocean understand that we're in a...
I apologize for that. So then that's called the house chore. This is unlimited. There's two parts to it. There's the limited house chore solution, and then there's the unlimited. This is part of the unlimited. They get 2 weeks to come up with a solution. And then there's the limited one. And the limited one, they have only about 10 minutes or so. And I pretty much provide all the different materials for this particular experiment, and I time their whole process. So I'm gonna go up here and look for the experiment. It's called PBL House Chore. And so as you can see from here, right here. So I give them like simple things, just like tape, paper plates, cups, paper clips, towels, brushes, like all this basic stuff. And I do like little amounts of things, and then I separate everybody into different teams. And then I give them like 10 or 12 minutes to come up with some sort of idea to use as a solution for a house chore. And so here are some examples. One of the best ones are up here, like this one, which is pretty much the one you watch on the video, which we already watched. And then this other one here.
Hello everyone, my name is Henry Ramirez, and today I will be talking about my PBO Level 1 House Chore Project Limited. Problem/purpose. For our class of engineering by design, we had to create some kind of contraption that we could use to help us do a house chore quicker and more efficient. Materials. Like stated before, this was a limited.
As you can see, the materials are like really simple things that we can pretty much find around the house.
Project, and we had limited materials to work with. And these materials were 5 paper clips, 5 folders, 20 centimeters worth of string, 10 empty bottles of water. Research. Since we had a limit in time, we could not research any possible chores we could use to improve upon or make more efficient. Procedures. So after entering into the class, Mr. Cepeda gave us about 5 minutes to draw and sketch out a rough sketch of our contraption for the House Chore Project Limited, and to do a materials checklist. In the next few slides, I will be explaining our design and how it works. Also, the procedures taken to create this model/prototype. Almost forgetting, the chore my group decided to attack was feeding your dog. So we created an automatic dog feeder. In this slide, you can see a rough sketch I did on my tablet. You can see a more detailed drawing of the feeder. Then we placed one plate on top of the box to create a platform which your dog would pull on to make the minutes of brainstorming in class. My group couldn't cut through. After time, so we went off on that idea. We began with building the body of the feeder. Now in that cup, we would place the straw so that when your dog was hungry, he could pull the straw and call it break on us when we presented it. And thanks for watching.
So anyways, that's his video presenting his whole project idea, which I like because they come up with a dog feeding machine, and then later on with the unlimited time and materials, they were able to come up with this here. They had a sensor here, they had a microcontroller with Legos, and then they were able to put some food out here and had that sensor. As soon as the dog was in close encounter with that sensor, then this will drop the food into the container. And so that was a pretty cool design or idea that they come up with during this experiment. The other thing I like is that they come up with skits and ways to promote their projects or announce their projects. And so here's another skit.
Do you ever just have like the worst chore to do? Like, what is that chore?
Clean the toilet floor. It's like super nasty and it smells horrible.
And it comes germs and that nasty stuff.
Okay. Well, this is our solution to it because it's the perfect thing to use for toilets, for maybe doing the floor too, I guess. But this is basically, I didn't come up with it. Toilet Cleaner 500. Okay.
Yes, it works. You put it on your toilet and it scrubs and washes your toilet at the same time. And when you're done with it, you just flush your toilet and everything is clean.
It's in every store, it's in a Gucci store, and
So as you can see, they have fun making skits, making videos to be able to promote their different experiments. So that was a pretty cool experiment. Here's another one. So this one, they don't actually have to build anything. They just pretty much have to do research about a different kind of engineering field, and then they have to write an essay about it. And within this essay, they have to search things that we let them know ahead of time. Like what would be the salary? What would you be working at? What kind of companies will hire you? What kind of classes would you have to take to be able to graduate in that field? How much time does it take to be able to graduate in that field, etc.? And so again, to be able to make connections with other classes, well, you can use this with the English department or ELA, and then ask them to check their grammar or the way they structure their whole sentences and things of that sort. So I think that's a pretty cool experiment. They don't have to build anything, but they have to do a lot of research. The difference will be that they will do kind of like a rough draft, and then they would do something more professional with the hardcover sort of deal. But that's that. This experiment here I like because they begin to do a little bit of sketching, and so they have to learn how to sketch, and they start from 1 dimension to 2 dimensions to 3 dimensions, and then they do 1 point perspective, 2 point perspective, and isometric sketching. And so they begin to sketch a little bit better. And so this whole experiment, it begins with a sketch like this one. Once they have the sketch of their house with the 2 point perspective, then they have to build it, and they have to pretty much, have that finalized sketch like you see here. Let me see if I can double click on it. But once they're done with that, then they have to look around their house for all these different materials. And then once they have all these different materials, then they have to build their prototype of that particular house or sketch that they had going. So that one is pretty cool. This one is called the crane, and so the crane is made out of popsicle sticks, it's made out of string, and it's made out of glue. And this particular structure that they come up with, it looks like a crane, and it has to be able to hold at least 15 pounds. And we use weight, and we use it in class, and we keep adding weight to it. And the kids love this particular experiment because they can see what will be the breaking point of their crane. And so let me see if I can find one. It doesn't seem like I published that one, but let me see if I can find another one. You can see the whole process, their feedback, and the different sources. Here's Weebly. Yeah, I couldn't find it. All right, but you get the idea. They placed it on a base, and then they add weight on one side, and then they find the breaking point. And you can use this PBO with physics because they also talk about structures and breaking points, and or you can use it with math, and or you can use it with English. So different ways of connecting with other classes. I think I already talked about this. They had to design some sort of car that is made out of edible materials, and then they have to raise their car. So that's a different project. This one, I already talked about this one. That's what they do, robotics. This one is called the robotic arm, and I love this particular experiment because there's a whole lot of different ways of dealing with this particular experiment or project. You can start with something simple as using just some sort of cardboard, a motor, and some batteries and a string. And with that, you should be able to make some movement going. This particular prototype here is made out of popsicle sticks and some strings to it. And then you have motors or servos here, motor controllers. And you have this package of batteries. And then you have push buttons here. And so if you push a button, you will activate one of the servos, and so it would kind of like move that hand or part of that hand. This other one is a little bit more complicated because this one is 3D printed and it has linear sensors. So they begin to do their own research about linear sensors and how linear sensors work and mirror your movements. And then this other one is like really basic. It's made out of popsicle sticks and cardboard, and it has different servos here with strings, and it has batteries here. So as soon as you make contact with the battery, then you should be able to make some movement. This particular prototype here is made out of Legos. So when you're home and you don't find materials, well, you can use whatever you have. And so they had a tons of Legos, and so they used Legos to be able to build the prototype. He mentioned he didn't have like enough money to build his experiment or to 3D print it. So he had this heating gun, and then he was using a structure made out of like different folded metal for the fingers and things. And then he put plastic bottles on top, and then he used the heating gun to melt that plastic and give it kind of like a form to make it look kind of like a hand. And then he attached an Arduino microcontroller with different strings, and he was able to produce some movement to his arm. It wasn't as elaborative as these other ones, but it still worked. Now, the twins here, they were able to build a prototype made out of 3D printing material, and they were able to learn coding. They're only in 10th grade. They were already doing programming and coding in Java to be able to make that particular project with that robotic arm. The robotic arm, it's a fascinating experiment because you can take it at all levels from middle school to high school. And the kids do not necessarily need to have that electronics background, because that's the whole reason of the experiment, for them to be exposed to it. So it doesn't matter what they do. It doesn't even matter if their experiment doesn't work at the end. It's mostly important about them to be exposed to working with microcontrollers, working with sensors, working with robotic parts. Some of them got the experiment a little bit more like high level, like them. They actually 3D printed. They use linear sensors, and then they were able to express during their presentation the whole mistakes that they made. This other one was more of a practice prototype. They had a piece of wood, and then they had this made out of little plastic. They have dental floss as their string, and then they had a servo there attached to a battery that's attached to a motor controller, in this case an Arduino. So with the Arduino, they were able to program something simple, and as long as they pushed that button on the Arduino, they were able to make some movement. So that was a success for them. And yep, that's it for the robotic arm. This other experiment or project, it's actually 3 different ones. The first one, the students have to do a little bit of research about houses and the things that they would find inside their houses, and they actually do a budget research, different salaries, different careers, and then they connect with other classes like that. But once they do the research, the way to approach this particular project is that they have to design first in their journal. And then once it's done in their journal, they have to pretty much talk to you about it. And then once they're done, then you approve just one room. That's where you start, just one room, so that they can experiment with different things that they can find around their house, so that they could create just one room. And then once they're done, then instead of one room, they create an entire house. So of course, they're going to get a little bit more time to be able to create more space and more things for an entire house. Like this one here, you can see all the different details on the kitchen. You can see like a lot of different space within the house. You can see how they were able to design their house. And so they have to design it in their journal first, and then they have to do it in software. In our case, they use Google SketchUp. So once they have the software, they're able to visualize what to find, the things to find there. Of course, they have to do a little bit of research to know what to find in the different rooms. And when we talk about budgets, they find out how much do they need to make each month to be able to survive on their own. So this is a pretty cool experiment. It's very real. Some students do a little bit less detail. Others add a lot of detail to their houses, or their houses look really clean. But everything in their house is custom made. And like this one is pretty cool, actually, because this one has this little garage door here that opens and closes, and it had this little motor on the inside. That one was pretty cool. Here we have different ones. We talk about the scales, because the things that they have inside their house, they have to make sense. Sometimes they have like a bed that's the size of the entire room, and then you're like, is that real or not real? And so they have to think about, oh, that's not real, because a bed shouldn't be that big. And then they talk about their whole layout of their house, and why is that the house of their dreams, and why would they like to live in a house like that. Because you can see all the different houses. This one was pretty cool too, because he had lights. So the kid actually add LEDs to it, and as you turn the LEDs, it seems like the house had lights on it. So that was a pretty cool house. And you can see all the different houses that they have, and of course they have to have that design. Um, and so that would be the second one. So the first experiment or the first project is would be one room. Second project would be the house of their dreams. So they build their house of their dreams. And then the third one, you involve the faculty or the staff at your school. And the way to do that is you give them to design a house for someone else. In this case, will be a staff member. And so, like this one is one of my favorites because this particular staff member wanted a restaurant underneath and they wanted to live on top. And so this one has the design of an entire restaurant. You can see the little tables there. You can see the bathrooms here. Everything is made out of kind of like glass. He has these towers to support. And then he had this whole apartment unit on top with a lot of details for a resting area, a masterpiece, for the person to live, a little fan or ceiling on the ceiling, and it was overall it was a great design. The teacher actually loved it, and she kept the whole project, and the student did not had any issues with that. Yeah, he wanted her to have it. So, anyways, so that's also a great experiment to be able to connect with other staff members and other classes. Um, so that you can get them involved, and then once you get them involved, then you do later on lessons like more, you know, academically oriented, like, you know, mathematics or physics or statistics or things like that. That's called the dream house experiment. This other one, this talks about the same thing. Nowadays that there are in home for doing that whole distance learning, this is a great experiment for that. And here's the video for that for this particular student. He talks a little bit about it.
Julian. This is my house project. My client, Ms. Duong. Thank you, Ms. Duong, for being my client. So I'll just start off how I planned it. First, I'm going to sketch up. First, I interviewed her, and then I grabbed every information she gave me, and I was able to build a SketchUp plan. And then I grabbed all the measurements I needed for everything that would be inside the house. I printed both of them out so it would be easier for reference. Well, I first started off with the wood foundation right here. And after that, I started off with the poster boards, which would be the walls. And for the wood foundation, I decided to do a certain pattern that some houses would use, kind of similar to my house. And most of the materials I used was popsicle sticks, the sconding, and Play-Doh. And the cost to make this house was like, at most, maybe like $15 because I didn't really use much from stores because I already had a lot of materials from previous projects. So
there you go. By doing projects every often, you can recycle some of those materials, but you can see their whole experience through those videos. It's always fascinating to hear their perspective through videos. This other project is called the aquaponics, and the aquaponics project is a combination of different things, actually. Here is pretty much how the project begins. And so you have a fish. It's like two living organisms. You have a fish that's feeding a plant, and then you have a plant that's feeding a fish. And so you have weekly updates so that you can pretty much see what the student did during that particular week. And again, you can use this particular experiment and connect with other classes and get some help on the writing, or get some help as an overall feedback, or like physics, get some help on the things that they're thinking of experimenting. And most of these things you can find at home, like little containers and things. They're just pretty much laying out at home, and you can use them for an experiment like this one. But with the different updates, you can see their progress, how they're able to build. This particular project, it's also kind of like you can use it for environmental studies or social studies, and kind of like study the environment or science, because you're using a plant. And so you can talk about how the plants grow, the different kinds of plants. You can talk about fishes, different kinds of fish, which ones grow faster, which ones don't grow at all, which ones died, why did they die. You can talk about the pH in the water. You can talk about using sensors, like using Arduinos to control those sensors and code it and program it. So, I mean, there's a lot of things that you can do with this kind of experiment, because you can use it for any field. And then, of course, you can ask them to create the whole website. And then once they're done, to give you the whole final results of their experiment and perhaps their feedback for their experiment. So that was kind of like how the experiment finalized. So that's another project. Here's this is part of the same project. This one is an obelisk, and this actually has two parts to it. The first part, they have to build an obelisk. They have to do a little bit of research to understand what an obelisk is, and then they have to find out what kind of materials they have at home so that they can build the obelisk. And then they build the obelisk and they put some writing there, kind of like the Egyptians did. But once they have their obelisk built, the second part of it is to how can they manage to raise the obelisk. And so they have to propose an idea. And from all the different ideas, I like this one the most because if you do a little bit of research about obelisks, you find out why. It's like the closest theory on how the Egyptians were able to raise that obelisk. And so the concept is they create this sort of room and then they fill it out with sand and they put like a little ramp on the side and then they roll the whole obelisk to the top of that particular room. And then at the bottom of the room, they have these holes that once they get rid of those holes, then all the sand comes out. And as the sand is coming out, then the obelisk slowly is like getting into place. We're talking about like 1,100 tons on weight. So that's a big challenge. So anyways, I love that particular experiment because it has two parts and you can use it with any class because you have to do a lot of research. We already talked about the age of technology earlier and the board games. This is called the fun theory project. They have to come up with the fun theory of making things to solution something that is going on in their school. In our particular school, sometimes it gets very messy with trash. And so this particular student come up with this sort of kind of like a court simulating a basketball game. And so she plays different courts at different trash cans around the school. And so students, instead of throwing the trash just like elsewhere, they wanted to like throw it into this little net here, which is a little bit more entertaining, thus the name Fun Theory. So that was a pretty cool experiment that we had going on in engineering. This one I already talked about is concerning the different ages of technology. And they had to pretty much create a board game. I already talked about the aquaponics project. This is for robotics. I do this with middle school students whenever I have to teach them a little bit about robotics, like the history of robots or the different kinds of robots. And so one of the first things I ask them is, hey, well, I need you to build me a robot. And so they have to come up with an idea and sort of use their perception of what a robot is and then put it together and present it during class. And then, of course, most of them go for a humanoid robot. And you could see other different perceptions of what a robot looks like. Everything has to be custom made. And so they have to decorate it and put it together. And then they have to do a whole presentation about it. And that's another way to connecting with other classes by doing that presentation, talking about it. So that's the robot project, and I use it with middle schools. This is for advanced classes. This is using 7-segment displays to create numbers, digital numbers. And so they have to do a little bit of research about how to create digital numbers using those 7-segment displays. Of course, we talk a little bit about theory during class, but then later on they do their own. In this case, they have to do their date of birth. And so they have to pretty much do the date of birth using 7-segment displays. But what's cool about this experiment is that not only like seniors or high-level students can like do it, we also have students that are not at advanced level and they can still manage to do that particular experiment. I think I just had it here. This one. So this is the same experiment, but this is in middle school. So these two girls were able to team up and they were working with microcontrollers and they were using this 7-segment display and they were able to display the different numbers on that 7-segment display with the different LEDs, turning them on and off, and they could understand a little bit about programming and coding and digital numbers. So you can use this at like all different ages. I love that particular experiment. This other one is for space exploration. They have to do a rover, and so they have to come up with some sort of rover machine that is going to explore space, and then they have to present their whole idea, and they have to justify whatever it is that they build. And then that's with their own materials. Once we're done with that experiment, then we move on a little bit to robotics, and then we use this prototype called Bobot. This is a kit that is sold through Pitsco, and the kids pretty much put everything together, and then they learn a little bit about circuits, they learn about sensors, they learn about this whole exploration of Mars, and so they have a better idea of what's going on with the rovers. So I like this experiment a lot too. That's called the rover design. I already talked about this circuit. I already talked about sound circuit. And here I have other projects that I've done for different classes. I think I talked about the different sound circuits that we've made. I didn't talk so much about posters. So when the students arrive, they have to make posters that have to do with engineering. And so this is a great experiment to use with other classes as well, because they have to write. So sometimes they don't write that well, or they don't know how to put things together, or they don't know how to use a particular software. And so that helps to connect with other classes and their grammar. So everything is related to engineering. Other than that, we have this other one deals with bridges. That's for a specific class. They have to build this sort of truss, and then they have to build this truss machine, and then they have to test how strong are these structures and find out the breaking point. And then they graph all that data. This is for manufacturing process. They have to do a little bit of research online, and then they have to search how things are being made, and so then they have to write everything about it, like the whole steps, the different things that come into place to be able to manufacture some sort of device on some sort of experiment. So that's for manufacturing. We do a lot of robotics related things. So as you can see from here, they have to. This is for the truss tester, for that machine that helps with truss and breaking points. They have to do it in their journal, then they have to do it in software, and then they have to test it and actually build it. So once that's done, this is for digital electronics. They have to create a map of a particular circuit, and they have to connect it and build it, and then they have to test it out. So that's a pretty cool experiment using gates and NAND gates. We were talking about robotic arms earlier. I'm very proud of them. These two girls were able to do their whole experiment 3D printed, and then you can see from here, like there's some videos where they were testing it here in school. They had to do different adjustments to their hand so that it can move differently. But they got really into it. To the point to where they even came back the following year and help out the kids of that generation in that particular class. So this particular experiment was a success, and they were able to see how it works and how to like put it together. So that's the robotic arm. We also have more simple experiments. Since we already have the robotics kits here, we do simple things like this one here. You pretty much build a toy, a pool toy. So they're working together here in class. Here's the pool toy, and then they have this sort of like platform, and then they add like stuff to it. Like this one is like a kind of like a Pac-Man, and it goes up and down. And that's called the pool toy experiment. Here we were talking about cars earlier and how they were able to make those cars, those edible cars. And so here are like some of the materials, and here are some of the cars, how they look like. I know I'm moving a little bit too fast. It's just that I'm kind of like running out of time, and I wish I could like present more projects. But here's the bridge project, and that crane bridge project that's made out of popsicle sticks, and how they tested during class. Here's microcontrollers and Arduinos. We have more Arduinos and sensors. We have 3D printing. We have robotics related stuff. Let's see what kind of other experiments. This deals with the house chore. He was able to make a coffee filter. That was a pretty cool experiment there. They learned how to like solder. They love soldering here. They were able to solder stuff there. So learning how to solder is pretty cool because it gets them really entertained. And so those kind of like tied into some, not doing projects, but like learning different skills. Here's that pool toy we were talking about earlier. Let's see if we can, as you can see, he pulls on the toy and then he creates some sort of movement. In this case, it's a ballerina that's like dancing there. And so, anyways, that's my time. Thank you so much. My name is Mr. Fernando Cepeda, and I'm from Harmony Science Academy in Dallas High School. Thank you so much, and have an awesome time.